Thank you, Martin. You can stop the screen share now, and I'll stop talking now and call on Charlie Conger.
Hi, Martin. That was an excellent delivery and content. Really appreciate it. I had about three or four.
Carry on.
I have about 3 or 4 questions to ask, and I'll try to keep them very short. On the Magico measurements, those were at what distance? Do you recall?
They would be all the distances I used to examine it. So for a tweeter, you can go quite close, removing reflections. For the room curves, it's out at 3 to 5 meters. I measure routinely at a range of distances to see how the integration changes with distance, whether there are phase anomalies which rotate. Sometimes you'll have a phase shift, and as you move away, the angle will rotate between the two sources. So I want to see whether there are dips in space moving away from the loudspeaker. But most of what you saw would be at 2 meters.
2 meters, perfect. And then you mentioned the loudness match within 1 dB or better. How do you achieve that? How do you define loudness match?
When I'm talking about comparisons of sound, for example, 2 CD players, I'll make sure that I can match the output within half a dB if I can. If I'm using a high quality preamp and I've got accurate calibration, then I can set that. And if I'm more than half a dB out, it's not as easy to get the exact comparison sound quality. It gets in the way, let's put it that way. You have to leave it longer. If you're a dB out, you have to keep listening for 5 or 10 minutes up to that particular section to adjust.
How about loudspeakers though?
Loudspeakers, you don't A/B loudspeakers. You don't have 2 loudspeakers in the room at once. You just listen to it.
I see.
The matching was for electronics.
Yeah, I see. You mentioned the range from 10 to 20 kilohertz as not being very important. So you mean not very important in terms of flatness or distortion, or of course harmonic distortion there would be way beyond audibility. But
well, the first harmonic, second harmonic of 10 kilohertz is already beyond audibility.
Correct.
The only likelihood of hearing distortion in a tweeter if it intermodulates badly, if it starts to rattle and overload. If you get to that point, then you'll hear subharmonics in the audio band, but that almost never happens with the tweeter unless you flatten it against the stops. So I think we take too much fuss. We're too fussy about tweeters. You can certainly hear whether they're smooth and whether they change the timbre, for example, of the violin. But at the same time, we're busy trying to make tweeters work to 50 kilohertz, but I don't think it has much effect on sound quality. We could spend the money better on the mid-range driver.
Excellent.
I think fundamentally, we're not viewing the spectrum from the psychoacoustic viewpoint, particularly when you realize that 440 hertz is where most three-way loudspeakers have a crossover, but that's the middle of the tenor range, and that's where people are singing, and you don't want some giant paper cone woofer changing over to a mid-range unit with a complex crossover and impedance problems just at that point. It's because of 20 to 20K. We are blinded by the 3 decades of 20 to 20K.
Absolutely, absolutely. And then one last question, and I'll relinquish my position. What is your stand on the importance of linear phase?
It's very low in the list of priorities, but if you can get it, it is audible and it's worth having. I had an interesting experience with DeViollet, the amplifier. As you know, this company has measured all the loudspeakers it can get its hands on, including the Magico. And they had a linear phase correction for the Magico, which I was able to load into the DeViollet's processor and switch it off and on. And it definitely sounded more open, more tuneful, and more gracious in linear phase mode. But if you take a percentage of overall sound quality, it might have been 3%. And that was for a speaker which is almost linear phase to 25 hertz anyway, by virtue of its sealed box design and its large volume, tuned volume. So if you can get it, I'm playing with linear phase at the moment with the German Fink loudspeaker, Karl-Heinz Fink loudspeaker, and that's a bass reflex which you wouldn't expect to set to linear phase, but he has the full correction coefficient. You can load it into Roon, and you can switch it on and off. And it depends on the program. If you've got program with extended linear bass and a good phase response, then you can hear linear phase in the speaker. But if it hasn't, then you can't.
Of course.
So
Thank you very much.
Depends how jumbled the program is.
Absolutely.
Okay, Alan Edelstein, you're next, and then John Atkinson after that.
Well, I hope I can make this clear. I'm always looking in my system, and I hate using this word in a way because it's undefined, for live sound. And it seems like live sound is pretty obvious to us. We know when we're hearing it versus recorded sound most of the time. And I think of and it doesn't seem to me to necessarily relate to flat response, because I think of two examples. One was an old issue of Stereophile where Gordon Holt reviewed the KLH-12 and had a discussion with Henry Close because he didn't think its balance was correct. And he changed the seat the next month at the Academy of Music, and damned if it didn't sound exactly like a KLH-12, and yet both examples sounded live. And then the other one I think of all the time is Out of a Room, where the frequency response is all messed up. But you know when there's live music and not recorded, or definitely not electronically amplified. And where I sort of gotten, and I guess comments on this, so measuring flat frequency response isn't, I guess, what I'm looking for. And I started thinking that what I'm really listening for is dynamic contrast. And that dynamic contrast is really the thing that, at least for me, makes me think of live sound, and that any amount of compression, even at many changes in level, or certainly in maximum changes in level, are what I'm listening for. And yet we always measure mostly frequency response or power response, but I don't see much testing of changing of level. And I guess I'm asking you to comment on that.
Lot of questions there. I'll make the first observation that I agree with you. When you hear live sound, it's unmistakable. Absolutely unmistakable. You can hear it from streets away. You know what it is, and it's nothing like any hi-fi you've ever heard. We live with substantial compression in the entire recording chain, reproducing chain. It's the best we can do so far. We do our best with it, but it's not very good, and it's not live. But with good recording techniques, with careful setup, you can get a musical experience which is enjoyable and which is satisfying. And there's no question that the lower distortion, the less compression, the bigger the magnets, the lighter the coils, the lighter the cones, the more dynamic it can become. And then there's this compromise. Do I let the system rip, even with resonances, because that gets me a liver effect? Or do I start to get a headache from resonances which are the same all the time? There's a ringing which you begin to recognize as inherent in the reproducing system and not in the music being reproduced. There's no doubt that the bigger the equipment gets and the more powerful it is, the more dynamic experience you can get. And the Chronosonic XVX definitely taught me that. The thing sounded amazingly live, and that's because it had a lot of drivers not working very hard at all. Lots of easy power, lots of thick cable with no compression, and drivers that weren't being worked too hard. So you could argue the bigger the better if you can afford it, but it's nothing like live.
Thank you. John Atkinson, would you like to unmute yourself?
Yes, yeah, that was a great presentation, Martin. Lots to think about, particularly the 3 dB dip in the presence region due to the angle the speaker axis makes with the ear. I can't help being an editor, and I have to point out that middle C is 262 Hertz, not 440 Hertz, because that's the A above middle C. Doesn't affect your argument at all.
Thank you so much.
I have to point it out. And I have one question, which is,
Go ahead.
panel speakers behave so differently in the room. They behave so differently in their dispersion, in their distortion characteristics. What's your opinion compared with, say, the Magico S5 that's your reference?
Well, there's a world of difference between a bidirectional panel speaker or a dipole panel speaker and a point source in a box facing forwards. And people have tried to put drivers on the back of box speakers to help that situation. You have to live with the fact that the rear sound of a box speaker is very different to the front sound. All the drivers are all shaded by the enclosure. So the sound at the back is quite different. So the ear has to begin to learn this dichotomy between front and back. They all have their merits. They all have certain qualities. And panel speakers have very low stored energy. They don't drive the room sides. If they're dipoles, they don't drive the room sides. You can get certain benefits. There's some rooms which only a dipole will work in. And there's some rooms where a dipole won't work in it at all. And the issue is getting power bass. If you like rock and you like good rhythms and you like to be driven fairly hard, it's very hard to get that kind of sound out of a dipole. And they've nearly always ended up with omnidirectional woofers underneath, which slightly defeats the point. So I think everyone has their own taste in music. Speakers reproduce differently. The designers do their best to make a good sound that's detailed and interesting and dynamic. And you take your pick, really. It's not a closed field at all. It's an open field.
We'll move on to Don Rutkoff in California. Would you like to ask a question, Don?
I would love to. First of all, thank you very much, Martin. A very, very excellent presentation. Things that I've learned probably from you over the years. My preferences, I've owned 5 pairs of speakers in my lifetime. 3 of them have been a ribbon type speaker. I own Heil AMTs way back in the 1970s. Then I had some Apogees, and currently I have Bollinger Graebners. So one question I have is, what is the pluses and minuses, the advantages and disadvantages of having a ribbon type speaker compared to a dome tweeter? And the second question I would throw is, are there a lot of differences among all the different brands that sell regular dome tweeters? Are they really different from each other?
There's a lot of questions there. Take the dome tweeters first. From the design viewpoint, they all sound different. And quite a lot of the difference is the surround, not the dome. As they bang up and down, the surrounds make a noise, and they're elastic, but they have damping on them and various other aspects.
So you mean the material that is the surround is made out of?
Suspension. If it's a metal dome and it's rigid, let's say to 30 kilohertz, they don't have a sound at all. You can't hear it. They're just little pistons, but it's the machinery around them that generally makes the sound. Interesting, isn't it? Go back to the other part of your question. What can you remind me of that?
Advantages or disadvantages of ribbon style speakers compared to domes?
Well, I'd probably get shot for this, but I think ribbons are the right kind of transducer for the treble. Large surface area, good coupling, good damping, good air damping, and their suspensions are much more linear because they're occupying a larger perimeter of the ribbon. So it isn't this little ring. Think of the dome rattling up and down. They rock as well. There are all kinds of poor dynamic aspects to dome tweeters. The ribbon is controlled in a space. It moves forward and back. It's driven over its whole area. Even if it does break up, you very rarely hear it. They're lower distortion. You've got a higher dynamic range. So I think ribbons are good. At the moment, I'm listening to ribbons off and on. I'm listening to the Fink loudspeaker as an accessory at this stage. And I quite like the tweeter on it, Karl-Heinz Fink speaker. Are you still with us? You're looking a little concerned. Dropped out?
No, we're still here. Samir, do you want to ask your question? There he goes.
Hi, Samir.
Okay, sorry, I was muted.
That's all right.
So I have 2 questions. They're kind of unrelated. The first one regards equalization. So, you made a very strong point about having, flat frequency response as being a goal. And, you know, most electronics have solved that, except for speakers and the room interaction with those speakers. And, you know, that's where I think a lot of the distortion in audio reproduction comes from, is the speaker. So given that equalization is so cheap nowadays and so sophisticated, you don't have to spend, you know, $150,000 to get a perfectly flat speaker anymore, like, you know, the Magical. You could accomplish this a lot less if you combined maybe a slightly flawed speaker with equalization. And I think, and the thing is with reviewers, and I don't know of a single reviewer that is combining those two concepts when they review a set of speakers. Here's a speaker, this is what it sounds like, but if we equalize it, this is what it has the potential to do. And instead, people are just, you know, upgrading at thousands of dollars and pounds to the next speaker instead of taking the existing thing and
I have a personal
$100 at it.
I have a personal response to that.
Yes.
You know, speakers are still very different, and equalization will not cure speaker faults, won't cure phase errors, won't cure errors of directivity, it won't cure distortion, it won't cure resonances. It'll cure broadband errors in tonal balance, but little else. And you're mainly correcting the room and not the loudspeaker. You can make an uneven speaker in a poor room better by equalization, but you can't make it a good speaker. It has to be inherent in the design and build of the speaker to begin with. You can make a good speaker better by matching it to the room, but you can't cure it if it's already faulty.
Yes, I agree with that. But I think there's a lot of speakers that are, you know, may have, let's say, crossover issues, where
It's very hard to cure a crossover with a reasonably broadband equalizer. You've got to get at the phase of the two drivers and microtune the phase of each section of the crossover so that they're better integrated.
Right, but you know, let's say
suppose it has a crossover flaw and it's in its energy response. You can correct it on axis with an equalizer and it'll be wrong everywhere else. On every other axis, it will be wrong. Until the drivers are well integrated and have a uniform output, you haven't got the basis to begin an equalization. You're correcting two wrongs.
If I could add, there are a lot of very good speakers that are voiced to be a little bright so that they stand out in the sales environment. So like the Infinity Primus series, they're very good speakers that could probably be equalized, as Samir mentions, to sound like many other much more expensive speakers.
Well, we're now suggesting that they're inherently good quality but bright, and equalization will solve their problems. The brightness may not be the worst of their problems. They may have other problems like ringing cones or poor crossover integration or cabinets that are inadequately made. You can take a sound and play with it. You can tune it up. You can help the room. You can help the speaker a little. You only go so far, but you can't make a bad speaker a good speaker with an equalization. It needs to be fundamentally better made, better designed, better constructed. And then you've got a foundation for improvement. That's how I feel about it. Not to say that equalization is a very inexpensive way of trying to fix some obvious problems which may be in the room or the speaker and would help you get there, but it's not the same as having a good product in the first place.
Martin, I see that in Hi-Fi Critic, you guys do headphone reviews. You've even reviewed Apple earbuds.
Mm-hmm.
What's your comment on how a recording engineer in the first place should monitor what is being put on tape or in the file? And then for music lovers, obviously headphones are going to sound wildly different than speakers. Is there a way how does a recording engineer deal with that? How do you make a recording sound good on both headphones and speakers?
Well, most engineers work with forward-facing monitors set up at a decent angle, and they're used to those speakers. They understand them, how they work and how they sound. And they can usually, with experience, voice recordings as they want them to be using that tool. It's a tool that they practice with. And when you put on headphones, it's totally different. If they're good at what they're doing, they know the difference with wearing headphones. They can adjust for it. That's a new mindset, new concept. So they go into that mode, and then they'll check that the mix will still work with headphones, knowing that straight stereo is their objective. And they work in near anechoic conditions. So they really are listening to the direct field that's on the recording. It's not corrupted by the kind of reflections that we have and put up with and really don't mind in a decent sounding domestic room. Most recording engineers work in very tight spaces, so they need to be virtually anechoic.
Alan, you have your hand up, but also you've had a question already, so I'm going to go to Andre. Would you like to unmute yourself and ask a question?
I think I'm unmuted.
Very good.
Thank you. First of all, I'm a big fan. I got your book when I was a graduate student in Cambridge in the 80s. So I've been a big fan for a long time.
Okay.
I would like to go back to the perception of what live music is like if you're trying to reproduce it. And you already touched on some of these subjects. Frequency response to me is completely relevant because human brain will adjust to it very quickly, just like we adjust to foreign accents. First few sentences, we don't understand the word, but then we understand pretty much everything the person says. Same thing happens with frequency response. If the person is facing you and talking to you, sounds live and sounds normal. They flip around and now they're facing away from you. It still sounds live, but the high frequencies are gone. But the liveness component is still there and you still understand what they're saying. So I'm also a big believer, being a scientist, in measurements. And I believe that if we could measure the right things, we could find correlation between perceived naturalness or live sound components. So the kinds of things you also addressed: is the speaker working in dystonic mode? Are there resonances, box resonances, resonances of the clone, resonances of the surround? Distortion. And we should treat distortion differently at different frequency ranges for obvious reasons. So in reviews, when a reviewer is commenting about the sound that he or she hears, a lot of it is driven by the acoustic environment that we're listening to. Reverberation of the room, how much absorption there is. And I have to admit, the most live sound I heard from a speaker was in an anechoic chamber, because I wasn't getting a mix of the reverberations of the recording venue and the listening venue. So for my personal pleasure, I would like a room that's very absorbent so that I can remove the effects of the room and I hear only what's on the recording. However, what I really want to do is get to the reproduction of live sound. And to get there, I don't think there is any other way than finding the right things to measure. And so I'm looking for your input as what you think would be the most important and significant things to measure. And if you know, how do we do it?
Well, that's a very difficult question, and there's no easy answer. And I don't think you're absolutely right. In your listening room, you become habituated to the sound of the listening room, and certainly major errors may continue to bother you. But you adjust to the room space, you adjust to the spatiality of it, where the reflections are coming from. When a person comes in your listening room and talks, he isn't grossly distorted by the listening room. He is that person in the listening room. And there's no reason why, for example, a mono speaker of good directivity reproducing a well-recorded voice shouldn't sound very similarly natural to a real person in that space, in that room. The room is not the problem. That the rooms change, everyone has a different room, but there's real live sound in those rooms, people who play music in their domestic rooms. It doesn't have to be a perfect room. Part of the issue is that the loudspeaker, most loudspeakers are forward directing. And so the rear sound is fairly colored, and that reflects from the back of the room. But you get used to that as well. As you listen to music, liveness is an emotional involvement with the program. If the music starts to work for you and it's entertaining, you're tapping your feet, you enjoy it, you're feeling connected to the recording studio or the band as they're playing, you don't care about the room or the speakers anymore. You dive straight into the performance and enjoy it for what it is.
Well,
And
if it's a piece I like, it could be a transistor radio that I have in my pocket and I'll enjoy the music and I'll tap my feet. But I'm trying to get to the fidelity thing, the recreation of the live event. And sure, if I put a saxophone or a piano in my listening space, it will sound live, but it will sound horrible most of the time, just because the acoustic space is not meant to be used for an instrument of such acoustic.
many people have pianos at home in a domestic room, and they don't say it sounds horrible. I shouldn't have brought my piano here. It's a waste of time. They adjust the room the piano's in and they play anyway.
No, I know, but that doesn't mean that that's the optimal way to listen to a piano.
If we're thinking of a construct where you walk into a space, let's say a space and not a room, and it sounds live, then your best plan is to be outside. You've still got reflections from the ground, but you'll have to accept that's normal for a musician or a band to be on the ground and to have a first reflection off that. And then you've got to say, well, let's not have any other reflection, just listen to direct sound from the performance. And the nearest you get to that is a marching band in the street. And I have to agree, that's a phenomenal effect. It's an amazing sound to hear a marching band in the street, away from all boundaries, long distance boundaries. But you can't do that at home. The part of this is that the recording engineers and the musicians playing are expecting you to be in a room with a pair of loudspeakers, because that's how it's done. So they adjust their recordings to give the best possible effect for your circumstances.
No,
you can't have them do that.
I understand and appreciate.
You're thinking there's some theoretical. Well, it's the dummy head, isn't it? You've got to recreate the dummy head where you have the illusion that all of the HRTF is included in the equation, and it sounds like you're in a live space, a genuine live space. You're not where you are at all. You're in virtual reality for sound. And we've had virtual reality sound with head-related transfer function recordings, dummy head recordings, and they are extraordinary, but nobody ever listens to them. You hear them once and then you walk away. You've got better things to do. It proves that it's possible, but it doesn't create music. It doesn't create a musical event.
Well, let's go back to the main point of my question is, what kind of measurements can we do to look for things that affect the sound to make it less than ideally live-like?
Well, part of liveness for me is pleasing dynamics, satisfying dynamics, contrast, the contrast between very soft and very loud. Does it go bang right from quiet to loud? Does it excite you? Does it involve you? Or does it sound compressed? Do the high levels sound thick and heavy? Or are they live and sparkling? That's dynamic range in a system. And the more you make it so, the better it gets. So take the Chronosonic XVX. The issue with that is it would play probably 20 dB louder than I needed to play it. And within the compass that I was playing it, its dynamics were excellent. It sounded really live. I wrote in the review how astonishing it was. I didn't expect it, that performers in the virtual soundstage sounded live. They sounded present. They were absolutely sharp, clear, dynamic, articulate, whatever you could wish for. It was a really impressive musical performance. It transcended the equipment.
Right, but in order for us to recreate that with other designs, we need to know what it is that makes it so good.
I would say it is dynamic range, absolute dynamic range. The ability to allow the peaks to go by without compression, without impedance modulation. It's inherent dynamic range. So it's linearity. It's linearity.
All right. Thank you for the question.